ideas. This is 4.6. It's operations with complex numbers. So it kind of stems from 4.5 and the multiplying and dividing radicals. So you'll need all of those. So if you missed any of those lessons, please go back and watch those videos. So we have a couple of vocab terms for this next lesson. The first one is just that letter I. So this stands for an imaginary number, and it's the square root of -1. So you know you can't take the square root of a negative number, so that's why it's imaginary. It's not real. We identified our real numbers back in chapter 1, but square root of a negative number is not a real number, it's imaginary. So I squared is the square root of -1 squared, which is just -1. A complex number is the sum of a real and an imaginary number. And then the standard form of a complex number is the real number, A, plus the imaginary number, BI. So whatever your imaginary number is comes second when you're writing complex numbers in standard form. And then conjugates, again, we identified in that last video of dividing radicals. But the complex conjugates are A plus BI times A minus BI. And this will always be a real number. So if you remember your shortcut for difference of perfect squares, so remember A plus B times A minus B is A squared minus B squared. Here it's going to be the same thing, but it's going to be A squared minus BI squared, which is B squared times I squared. And since I squared is going to be a real number, -1, this will always be a real number. So let's look at a few, let's look at that flow chart for complex numbers first, and this is the next part on your note sheet. So your first part of a complex number is the real part, and then the second part is the imaginary part. So with real numbers, you have two types of real numbers. You have rational real numbers, and then you have irrational real numbers. So a rational real number would be like 2, and an irrational real number would be like the square root of 3, where it goes on forever, non-repeating. So if you look at your note sheets, you get this key concept cut out, and the first property says that if r is a positive real number, then the square root of -r is I times the square root of r. So the square root of -5 is I times the square root of 5. So by looking at property 1, it follows that I times the square root of r squared is equal to -r, because it's I squared times the square root of r squared. So it's I times r or sorry, it's -1. I squared is -1 times r, so that's -r. So for example, I times the square root of 5 squared is I squared times square root of 5 squared, which is 5. So this equals -5. So let's look at a couple of examples performing operations with complex numbers. So we're going to solve for x. So the first thing we want to do when we solve for x is we want to isolate the x squared term. So we're going to subtract 3 from both sides. And we get 2x squared equals -18. And then we can divide both sides by 2 to isolate our x squared term. And we get x squared equals -9. Now again, you've always learned that you can't take the square root of a negative number, but now that we have these imaginary numbers, we can do that. So we're going to take the square root of both sides, and we get x equals I times the square root of 9, which is x equals 3i. Or sorry. Let me rewrite that. So the square root, if you look at that last property, we're going to say the square root of x squared is x. Equals I times the square root of 9. So x equals positive or negative 3i. Because the square root of 9 is either positive or negative 3. And we're multiplying that by I. Alright, let's look at this next example then. Solve for negative x squared minus 4 equals, and on your note sheet this actually should say called. I think I corrected it, but I didn't update the smartboard. Alright, so negative x squared minus 4 equals 12, so we're going to add 4 to both sides. So we get negative x squared equals 16. And then we're going to divide both sides by -1 to isolate our x squared term. So x squared equals -16. And then we can take the square root of both sides. So we have x equals the square root of -16, which is I times the square root of 16. So we have x equals plus or minus 4i. And actually for these, since I is the square root of -1, you're not really in your simplest form. So if you don't have that plus or minus, that is kind of a given while you still have I in the variable. So I leave it there usually just because eventually you're going to be adding and subtracting these things and you don't want to forget about it. So I just always keep it there. But if you drop it when you're multiplying, and you still have a radical, it's not wrong. All right, so let's look at the next 2 examples. So example C, again, we're trying to isolate our variable, our x squared term. So if we subtract 2 from both sides, we have 5x squared equals -10. Divide both sides by 5, we get x squared equals -2. And then take the square root of both sides, we get x equals square root of -2. And again, if you look back at that first property, if r is a positive real number, which 2 would be our r in this case, then the square root of negative r equals I times the square root of r. So we have x equals I times the square root of 2. All right, this last example is a little bit different. So if you remember from 4.5, when we're isolating our x squared term, we do not want to FOIL if we have a variable plus constant. We don't want to FOIL that out because in order to solve with square roots, we cannot have a linear term. And if we FOIL this out, we'll get a linear term. So we want to leave at u plus 5. That is going to be our squared term. So we're going to divide both sides by -6. So we get u plus 5 squared equals -20. And then if we take the square root of both sides, we get u plus 5 equals the square root of -20, which is u plus 5 equals I times the square root of 20. We can simplify the square root of 20. So our largest perfect square is 4. So u plus 5 equals I equals 2i, equals 2i times the square root of 5. And then to solve for u, we subtract 5 from both sides. So we have 2i times the square root of 5 minus 5. And again, if you have this plus or minus, that's fine to keep it there, but since we still have a radical, we don't really need it because we're still multiplying by a radical. Okay, the next step is looking at the sum and differences of complex numbers, and again, this is why often I keep that positive or negative so I don't mess up my signs here, and so I don't mess up my answers, my final answers. So when we're adding complex numbers, we want to add the real part and then add the imaginary part so we can get it into standard form. When we're taking the difference, don't forget to distribute up this negative sign. So this would be a plus bi minus c minus di, which gives us a minus c plus b minus di. So we're going to write each of these expressions into standard form. So we're going to use the FOIL method or the distributive property. So we have 5 minus 10i plus I minus 2I squared. So the first thing I would do is get rid of that I squared to make it into a real number so that we can combine our like terms. So I'm just going to rewrite it 5 minus 10i plus I minus 2i squared is minus 2 times -1, which is adding 2. Right, I have to make a correction. I was, for some reason, multiplying, and here we should be adding. So please erase what if you copy down, please just erase. So I was thinking, and this is an addition sign, not a multiplication sign. So let's try this one again. So 5 plus I plus 1 minus 2i. All right, so we do not have an I squared in this problem. So we want to combine our like terms. So 5 and 1 are like terms, and I and negative 2I are like terms. So if we add 5 and 1, we get 6. If we add I minus 2I, we get negative 5. So that's in our standard form. We've got our real number first, and then our complex number that follows. All right, for this next example over here, this is when we need to distribute. We need to distribute this negative sign. So I'm just going to rewrite it. 2 minus 6I minus a negative 10, which is plus 10, minus a positive 4I, which is minus 4I. So again, now we can combine our like terms. So 2 plus 10 is 12. Negative 6I minus 4I is negative 10I. All right, and then finally the third one. Again, distribute out that negative sign. So 3 minus 7 minus 8I plus 5 minus 6I. Remember, addition is commutative, so it doesn't matter which order you go in, but you do need to take care of your parentheses and multiplication first. So 3, so we can combine our like terms, 3, negative 7, positive 5. And then our I terms, negative 8 and negative 6. So 3 minus 7 is negative 4, plus 5 is 1. And then negative 8 minus 6 is negative 14. So the last one, our answer is 1 minus 14I. All right, then let's look at this last section. To multiply two complex numbers, use the distributive property. Or the FOIL method. Okay, so this is where we'll get our I squared terms, but we need to use the FOIL method. So 1 times 3 is 3 plus 5I minus 12I minus 20I squared. So here's where I'm going to rewrite to get rid of that I squared so that I can combine my like terms a little more easily. So 3 plus 5I minus 12I minus 20 times a negative 1. I squared is negative 1. So now I can combine my like terms. 3, and this ends up being a positive 20. So 3 plus 20 is 23. 5I minus 12I is negative 7I. All right, and then the last problem, or the second problem here. Again, we're going to use the FOIL method. So we've got 16 plus 20I minus 20I minus 25I squared, which is negative 5. Now, if you notice, this is the shortcut. We use the difference of perfect squares, or the difference of squares shortcut, which is A minus B times A plus B equals A squared minus B squared. So if we recognize that before we use the FOIL method, we can use that shortcut. Otherwise, you're going to get the same answer if you FOIL. So here, these cancel out, so we are left with A squared, which is 16, plus 5I squared, which is, minus 5I squared, which is 25. So, which is negative 25. So our A squared minus our B squared, which is 16 minus negative 25, gives us 41. So 16 plus 25 is 41. So again, don't forget that difference in perfect square shortcut. If you can recognize it, otherwise using the FOIL method is a little bit longer, but it'll give you the same answer. Then the last section, a complex number is not in standard form if I is in the denominator. Just like a number with radicals is not rationalized if the radical is in the denominator. So you can use the complex conjugate to write a quotient of two complex numbers. So again, the complex conjugate is a plus bi times a minus bi, and that'll give you a squared minus bi squared. So we want to get this imaginary number out of the denominator, so we're going to multiply by 1, and we're going to use the complex conjugate. So 1 minus I over 1 minus I. So that's 1. Any number over itself is 1, so we can do that. And then we need to use the FOIL method. So again, it's this whole group and this whole group, so multiply the numerators and multiply the denominators. So we got 6 minus 6i minus 4i plus 4i squared. And that is over our a squared minus bi squared. So a squared is 1 minus I squared is negative 1. So now we have to simplify. So 6 minus 10i plus 4 times negative 1 is minus 4, and that's all over 2. So this is 6 minus 4, which is 2 minus 10i over 2. And then we can divide each term in the numerator by 2 to get rid of our denominator, and we end up with 1 minus 5i. All right, then if we try the next problem, got the square root of 10 over the square root of 10 minus I, we're going to multiply by the complex conjugate over the complex conjugate. So square root of 10 plus I over the square root of 10 plus I. So in our numerator, we end up with square root of 100 plus I times square root of 10, and we'll simplify at the end over the square root of 100 minus negative 1, which is our I squared. All right, so remember when you simplify square roots, you have a positive or negative. Since we're adding and subtracting, so we're adding in the numerators, well, actually we're adding in the denominator too. But you want to remember that the square root of 100 is positive or negative 10. So this means positive or negative 10 plus I times the square root of 10 over positive or negative 10 plus 1. So we have two answers here. We either have, if we choose to go with the positive 10 as our first solution, so let's do that one first. So we have positive or negative 10 plus I times the square root of 10 over 10 plus 1, which is 11. Or we have, if we use the negative 10, we have positive or negative 10 plus I times the square root of 10 over negative 10 plus 1, which is negative 9. So again, don't forget when you simplify square roots that the square root of x squared is positive or negative x. So please jot down any questions that you have, and we can go over that next time I see you. Thanks.